This is Andy Zaski, VP of Sales and Marketing at Tolomatic, and I wanted to welcome you to another ToloTalk webinar series. We really appreciate your participation, and hopefully you're continuing to find these various topics. We're now presenting once a week, interesting and engaging. In this case, I wanted to take a phrase that we've actually trademarked called endurance technologies and dig into that, kind of unpack what does that mean for Tolomatic and what does that mean for your customers. And so the first slide here, I just put a couple of other brands that sort of have that tough mentality to them, be they Ford, John Deere, Gorilla Glue, etc. All those things I think resonate with sort of that mindset of if you need something that's dependable, reliable, that you can drop once or twice, can take a little bit of a licking and keep on ticking, as it were, then there's a variety of products that sort of aspire to that, right? That endurance technology. So, and I, at the very bottom here, the caveat is, if you do need that right product, then oftentimes you're willing to pay for it. And Tolomatic's never been the least expensive product line out on the marketplace, and endurance technologies and our philosophy around that is part of it. So what I'm going to do is spend a little bit of time talking about what does endurance technology mean to us. And then I'm going to talk a little bit about some of the things that we as a company do that support endurance technology, talk briefly about a couple ways our products are designed with that in mind, and then finish up with some applications at the end to give examples of actuators in an endurance technology type of environment. And I think, hopefully it'll be interesting. We'll take you through a little tour here and should end on time. But this is some history here that I didn't know, but at the top here is something that Keith Hogan shared with me. One of our customers at one point said, your actuators are built like a tank and run like a deer. We took that thought process and said, you know what, we really do pride ourselves on making something that's going to last for not just days or months, but years and years. And we actually have examples of actuators that have come back 10, 15, 20 plus years after we put them in service. And so we took that idea and then we coined this phrase, endurance technology. And, what do your customers want? Those three bullets there, they really want to have confidence, right? Sometimes you're putting your reputation, sometimes even your job on the line when you make a selection for some of these key products in a really critical application. You want to make sure that company is going to help stand behind that product. You want it to work perfectly, but sometimes there's mistakes made on the design side. There could be mistakes made on the installation side. There could be mistakes made in the assembly side. And then how do you respond to that? And what do you do in that situation to try and make it right? And then finding good technical support throughout this entire sales process is another key piece. So all of that, comes and really is embodied in this idea of endurance technology. So just a couple thoughts. What is endurance? I really like the middle piece here. Strength. Continue despite fatigue or stress. In adverse conditions, and many times our actuators are put in environments that are not optimal for most other actuators, or they're asked to power through and work for long periods of time, or take splash downs in water, things like that. So that's the endurance part of this phrase. And then the technology piece, we do spend a lot of time, and I don't always think about an actuator as a intricate technological wonder, but there's a lot more that goes into the actuator design than one might think. And our Director of Engineering, Gary Rosengren, continues to enjoy enlightening me about that fact as we go on every week here. But, machinery and equipment developed with scientific knowledge, and then sometimes with applied sciences here where, and we'll show you how we do testing in our facility to ensure that what we've designed is going to work the way that we expect it to. So, this endurance technology mindset goes all the way back to our founder, Burton Tolles. We started in 1954. Over 65 years of these quality products that we've been seeing out in the marketplace, and really a reputation that has been built over that time frame for this type of product, this endurance technology product. So all the things along the right-hand side here, and you can read them on your own, but are really things that we've put a lot of focus on and prioritization, putting the quality and reliability in front of that price piece. So we might be more expensive, but making the right decisions to have the right piece of equipment and or subcomponent in that equipment. Really this vertical integration, trying to do a lot of our own activities. So we do have some key pieces we have to source from vendors, but a lot of other things we try to control our own destiny on. We do put a unique serial number on all of our actuators, and we test them. We test them both pneumatically and or electrically prior to them shipping out, and then we record that test information. So we've got that available for you and your customer. If something's not working the way they thought it should, let us know, and we can pull that test data and share that with your customer about what we saw when it left our factory and what you're seeing here. And then we'll talk a little bit more about this, but you know, things aren't going like we hoped they would. We get fire drills here, and we have sometimes turned around actuators in 6 hours, gotten it in the morning, fixed it, and gotten it back out the same day, or then 24, 48 hours when customers have critical situations. Sometimes takes us, if it's not as critical, 1 week, 2 weeks, 3 weeks, something like that. But having that returns material piece of our business located right in our facility and ingrained in our operations team really means they have access to all the right parts at all the right times. So that's a key piece. So we did a little poll here. Teresa Wallace helped me with this. What does this mean to our employees? And just about every single facet of our organization really thinks through and embodies this endurance technology in the way that they do things here. And design engineering in the middle there, how do we make this product more robust and making it last a long time for the customer? So that goes also into the application engineering team, just not just guessing about what the application might be, but really trying to pull from you guys out in the field, what is the customer really trying to do? So we make sure that we accommodate their requirements. We want to engineer it to the right specifications, not over or under. And so I know that gets challenging sometimes because we're asking for more and more information, but it really helps to ensure that we get the right product for the right application, or as best that we can with the information that we all have, right? That it goes all the way down through here with assembly and shipping, trying to make sure that everything is packaged appropriately and delivered to your customer and arrives in a good state. And then quality down there. We do have our quality team here. We've got a very involved quality process. Whenever there's an issue, we launch an internal investigation into that and then take steps to work to ensure as best we can that doesn't happen again. So there's a whole process around that that's embodied in our ISO procedures. And rest assured, we're not perfect, but when we do stumble, we try to recover quickly, and then we try to do our due diligence so we can avoid doing that again in the future. Just a quick overview here. This is where we were a year ago. So Tolomatic with the Tolo ball out in front here. And then endurance technology. I'm not sure exactly when this was coined, but it looks kind of like a riveted nameplate you would put on a piece of robust equipment. And so it sort of embodied that endurance technology idea. But both of them seemed a little dated. So about the first of this year, we dropped that ball off of here and just went with a more simple logo here, Tolomatic. And then as we looked at endurance technology, it did start to look a little dated, 60s, 70s-ish, maybe even 50s-ish. And so we decided to enhance that and update that look. So you can see that embodied here. Sort of, this is where we're headed. So don't be surprised. There will be a mix of literature over the next 6 to 12 months. There's only so many people that can work and update information here at Tolomatic. So we're stepping through that as quickly as we can. But you will see some stuff with the top, some stuff with the middle, and then the new stuff will all be with this this bottom branding framework to it. So and see that you'll see that continue to evolve and be more prevalent in our literature and our website as we go forward. And then what does that do? That that blows down into all of the literature itself. So when we talk about endurance technology, typically we're doing call outs here. And this is what it used to look like. And this is a design here just to show you kind of what the new look will look like. I think it's cleaner, more modern, gives your customers a sense that they're working with both a historic but contemporary company as well. So how do we embody that at our facility, and what do we do differently at Tolomatic that really supports that endurance technology mindset. This is a quick snapshot of, so a few years ago now, our engineering lab. I've added a couple new things here, but every single roller screw that we developed and manufacture here, we have done numerous cycle tests with here in our facility, stroking that thing back and forth, pushing against hydraulic cylinders at high forces to verify that everything that we've designed will work as expected. All of our RSX actuators that we've launched in the last 2 to 3 years here have all been qualified for months of testing here, stroking up and down, pushing up to 50,000 pounds of force on some of these, and or pressing applications, etc., to verify that the technology that we've built into this actuator will do what we said it will and will last as long as we said it will. So we don't even, we don't just say endurance technology, we really walk and our talk here. We also do a lot of subcomponent testing. So if we're going to go with a new bearing supplier or a new ball screw supplier or something, oftentimes we will bring those products into our engineering lab here, test them to ensure that they're going to work the way we expect prior to putting them inside of our technology. We've got new ideas that we're constantly toying around with, and we'll talk about a few of those as we go forward here. But this is the space that we then take and put together some experimental design things and see what kind of results that we get. Last piece is maybe the most important one as it relates to our distributor sales team. This is the space also that's available to you and your customers. So if they have an application and they're a little unsure, say they're most comfortable with hydraulics or pneumatics or something, and they really are, this new technology around electric has them concerned, sometimes we've been able to set up an example of their application and run it here. And we'd love to have them come out and visit and see that. Or in the COVID situation here, we'd be more than happy to do a Zoom meeting with them and have them physically see what's happening here and get some of the data and observe the actuator in process. So keep that in mind as you come upon customers that may have concerns or some unsure how to approach this. We can hopefully help with that. We hope everything goes smoothly, but sometimes they don't. And so this is our return materials area. This is where anything that has an issue comes back, and we've done a nice job of cleaning this up. This is on the back side of our facility, but it's right near all of the machine shops, the assembly area. This is the area that they bring product in, they'll strip it down, they'll do some testing on it. We take photos, we put together a quick report on what we find, and then if it's a warranty situation, we'll repair it. If it's something that the customer would need to pay to repair, we'll get that quote out. And or if the customer says, you know what, you're right, it did its job, it's lasted as long as it could, and I just need to replace it, then this is the place we toss those out then and build them something new down the line. So a lot of activity here. Again, we have the ability to do a quick analysis, really can do some pretty fast repairs if it's required with a customer line down sort of situation. A lot of capability here, and help to troubleshoot. Sometimes there's some misalignment. Sometimes the customer crashed into the hard stop. We can find some of the telltale signs of what actually happened and then talk through, how do we make sure this doesn't happen again. So one of the things I just want to do is talk through one example of a rodless and one example of a rod style actuator. So this rodless actuator, some of the different pieces here, you could say, hey, well, I can get a cheap rodless actuator on the internet, or I could even make my own, etc. Why would I bother buying a Tolomatic at 3-5 times the price of some of these other ones? And it really comes down to this whole endurance technology mindset. So our stuff is built to last a long time, to carry heavy loads, to be in difficult situations and stroke back and forth for a long period of time. And there's a lot of technology that's sort of hidden inside a relatively simple package. And the callouts, work pretty good to highlight some of that. But everything from this type of material that we use for the banding, how it's sealed, how it sits in there, this patented V-wedge bearing system on a B3W series, or we use THK rails on our MX product. The type of belt material that we use, we have a couple different options here depending on the duty cycle and the forces required. the type of pulleys and pulley stock that we use, our ability to engineer and machine those, and the couplers that are chosen to attach motors to drive this system. How, the loads and the moment loading capability, how you're going to be able to tension this, how you're going to be able to service this long term. Some of the documentation we put together, from part sheets with blowouts and some manuals with assembly instructions, so you can do some of the service work yourself, and then others you need to bring back and send to the factory. But put some bumpers on the end of travel here, wipers and scrapers, very subtle things that make a huge difference to keep things out and to ensure this actuator is going to run for a long period of time. And then we do the same thing on rod style actuators. We have a couple different options here. Here we have got a steel thrust tube. We've done a salt bath nitride treatment on it. So it's not just a steel tube, it's actually treated. It's treated so that most of anything that would be working in the environment around this actuator is going to land on here and then fall off as it's stroking back and forth, and try to avoid getting that junk back inside the actuator. We've got field replaceable seal cartridges here. So how's that designed? What kind of material? There's a lot of actually technology in the seal itself that's used. What's the geometry of that seal? What's the material of the seal? What's the angle of that seal? How do you get it in and out of there? Different screw technologies that we use here, both from Acme ball and roller screw. The roller screws obviously are built here at ToloTalks. How you attach your motor, what does this plate look like? How do we do your motor here program so that it attaches smoothly and gets good engagement? What kind of tolerances do we allow on these pulleys here, and how they connect to the motors and or the drive shaft here? What kind of bearings and how many bearings are here in the back and here in the front? What kind of IP rating and why? Did we just slap on an IP rating, or have we actually done testing on that to verify that? And we kind of run the gamut. Adding this grease zerk, in this case an RSX has a grease port on the side of it, but a grease zerk on the new thrust rod for RSAs and IMAs allow you to do maintenance in the field. So trying to think ahead and how to help our customers to ensure that they can quickly maintain this product for years in the future, and hopefully avoid any sort of issues while the unit is running. And then we've done a lot of different coatings, painting, and you'll see a little bit of that. Not quite the next slide, I guess 2 or 3. We do have a number of different options. So every single application is a little bit unique. And what we try to do is not just use a square peg in every single hole, be it round, square, or triangular, but have the right tool for the right application. So in some cases, an Acme screw here, be it a Delron screw like it's shown here, or a bronze nut or something like that, is the right product for that application. In other cases, we need something a little stronger, more robust. That's going to be a ball screw and much higher efficiency, so it can move faster. And then in other cases, you need that roller screw technology. You need something that's really going to last for a long time, have a lot of force capability in a pretty small package. Depending on what you're trying to do, there's lots of different reasons to choose different technologies. Just to highlight for you, our core technology here that we've developed at ToloTalks is the roller screw technology. Again, we sell a lot of ball screws in actuators as well. But for those really tough applications, this is the technology here. And you can see the individual rollers. You can see this nut assembly here with the spacer rings. The nut housings back here, excuse me, that slides over the top and encapsulates this piece here. And then you've got the screw or the spindle down the center here. So all of these pieces are actually machined here at ToloTalks. There's special materials that we use. There's special hardening processes that are used. There's special grinding processes that are used. There's a tremendous amount of metrological quality assurance testing, dimensional tolerances, etc. It's quite intricate here and involved, but everything's been done with this Endurance technology mindset to both put it together as a finished unit, but then also to test the heck out of all of these different various diameters of screws and leads of screws that we offer here at ToloTalks. And then sometimes our standard product offering isn't enough. And so in this case, we can do modifications to take our standard product and then help to make it last for a long period of time in a customer's application. And we've had customers come to us with competitive product to say, hey, well, this seems to work. We said, well, it will for a month or two, but it's not going to last for 12 months or 3 years or 4 years or 6 years. And so working with them to understand the environment they're going to put it in, the stresses they're going to put on that unit, um, how are they asking that unit to operate? So we've done a variety of coatings. You can see one here, a blue coating and an extra black coating here. This is an RSX unit. This is a rodless MX product. We're actually looking at oil-cooled RSX units. So those are on test right now in our engineering lab. I talked about it earlier. If you've got an application where the temperature is kicking us out and allowing us not to be successful, here's a technology concept that we're exploring to try and add capability so we can handle that application. We've done water-cooled IMAs down here. IMA, because it's got the motor and screw actuator all integrated into one, this is an area where they can generate a lot of heat. And so what we've got here is a cooling envelope wrapped around that IMA, taking that heat away from the unit, allowing it to run cooler. And when it does that, it allows it to have a lot more life to it. So done things with multiple carriages here. You can see on this side here, 1, 2, 3 carriages. What that does now allows you to handle a much greater moment loading capability. So you could do it with 1, but it wouldn't last very long. You do it with 2, lasts longer. With 3, even longer. So depending on how high, what the weight distribution is, where the center of gravity is, how things are hung over the side of this unit here, all would affect some of the choices we would make here. So just gives you a sense of some of the modifications that we do, all in the pursuit of ensuring that endurance technology mindset for our customers. And then these are examples of actuators that have been run hard and put in difficult situations. So this started black, right? So this is our BC series, our band cylinder series of actuator. Used to be black, now everything's been stripped away here as this thing's been stroking back and forth at a long period of time. The customers put them in really challenging applications. So I don't have quite the right timestamps on some of these things here, but sometimes people put loads on here that they're not supposed to. Things get, you can see the scarring on the surface of the actuator here. So all these are examples of reasons that we need to make sure we design the application correctly up front, that they're going to want a really robust actuator, and that even with the best of endurance technology built in, sometimes things get even more challenging. So one of the other things that we do on modifications, as I look at all of the debris in here, is we can put purge ports in there. So you could put a purge port on here, attach positive air pressure to the inside, and try to blow some positive air and maintain a positive pressure internally to try and keep some of this crap from getting inside the actuator there. So what is an endurance technology application? Well, first thing to make sure we understand is what is not an endurance technology application. So if you have a very low duty cycle, sort of easy application, that's typically not where Tolometic's successful. There are low cost actuators available on the internet, some for $150, $200. This is not where we play. If you sit down in your car seat, there's lots of new electric actuators in there to adjust the seats forward or backward, or close your trunk, etc. Those are actuating 1, 2, 3 times a day, maybe 1 or 2, 3 times a month. So that's not a high duty cycle application. The dentist chairs or hospital beds, your desk, if you have one of the desks that rise and lower, those are not high duty cycle applications. So what is high duty cycle applications? Automotive assembly, something that's really in there working, right? You got parts coming down the line. Food plant, where they're processing, those things run 24/7. You have to stay up. Packaging or material handling, things are flowing all the time, moving through the system there. There's a number of other additional applications and industries that we could touch on, but this gives you a sense. We want something where the actuator is going to be stroking 70% of the time typically. So if you think about that, that's 20 hours out of 24, something like that, and moving pretty frequently. Or sometimes there are some low duty cycle applications, but they're really a critical application. You have to reliably make sure that this actuator is going to work every time and do exactly what you want when you want it. And there are examples of that. A medical procedure. This actuator may only actuate 3 or 5 times a day, but when it actuates, it has to happen, and it has to happen correctly. Defense, we do a lot with security barriers, and there's other things in the defense sort of environment where you wouldn't very often actuate, but when you do actuate, it's got to happen right now, and it's got to be right. So inspection and testing, those things are more precision based, probably lower duty cycle, yet a key application. So duty cycle is a key barometer for us on what is a good application, a bad application, but it's not the only one. There are oftentimes some critical applications that have a low duty cycle mentality, but they have to happen when they are required to happen. And I'll give you a couple examples of that. So, here's a high duty cycle application in the timber industry. We've got a planing system. So obviously in today's environment, we want wood products for toilet paper and Kleenex and paper towels, etc. These industries are running flat out. We're doing cardboard boxes, packaging material, everything that's being shipped around. The timber industry is going crazy. They've typically done a lot with hydraulics. Whenever a hydraulic hose has a leak, then that oftentimes ends up scrapping a bunch of products. So, and/or has environmental concerns. So, this is an area that's really interested in moving more towards electric. But these are tough applications, right? They're flying boards and trees into these lumber mills every day, day in, day out. It has happened 24/7, and these are endurance technology type applications. You could have a defense or security barrier application. So these, when they pop up, they need to pop up, and there's ratings on how quickly, 1.4 seconds, I think, is typical. You got to get from 0 all the way to extend, full extend, and then you got to hold that there and withstand a strike of a vehicle. And so this is not a high duty cycle application, but it is a critical application. And in this case, there's a number of applications here that used to be done hydraulically, but you can see where those hydraulic cylinders and hoses and stuff are located. They are in the ground, right outside. And so they see a lot of snow, a lot of variety of temperature. They also are very close to the ground. And so concerns about containment of hydraulic fluid that might leak out have prompted most of the industry to start moving over to electric driven actuators for these key or critical applications. Here's an example of endurance technology in a rodless application. So this is a machining center, machining extrusions. We got a 3-axis system here, X, Y, and a Z. This has to make sure that we keep all the material out of this actuator. It's got to move to the right position. It has to make sure it doesn't bend. There's no vibration. It's completely rigid, and it's going to be moving as they process the equipment throughout, an 8 to 16-hour day while they're out at a job site putting up a new facility here. So again, this has got to be running smoothly in a very reliable and efficient manner. And that's why people are buying into the endurance technology mindset there. There's another application. We got a food processing application, meat and food. This is actually a pump. There's a hopper filled with meat here. The meat pieces fall down into a capture area here, and then there's pistons driving this out and creating your salamis and your pepperonis and some of your deli ham pieces where you get slices off of, etc. So these things are pumping 24/7, especially in today's world where we're all hungry and many folks are eating more at home. These applications have to keep running all the time. So high duty cycle, high force, high reliability requirement. Another great example of endurance technology. Here, these are a couple axes, multi-axis and gantry type systems. So we've got B3Ws, GSAs. Again, anything that's doing material handling here. This is a sheet material that's being handled. This is going to keep feeding, right? So the product's going to keep coming. This actuator setup and system has to continue to move product along left and right. as things go along, or the entire system gets backed up. So this would be a constraint point in the manufacturing area. Here's another example, sort of same sort of deal, transferring glasses. Could be drinking glasses, could be beakers for samples, medical applications, etc. But it's got to keep moving and be very reliable, very precise, sort of a 24/7 type application. Again, an endurance technology application. Another example of a low duty cycle application that is an endurance technology one. Here is a contrast media injection for CT procedures. We are only going to stroke this actuator a couple times a day as they do procedures, but when it happens, it's got to happen on time, as planned, and very precisely, as we're injecting fluid into the human body. So again, another example of a lower duty cycle application, but a very critical application. And we're seeing more and more medical applications actually brought to Tolomatic, and I'm excited about our opportunities there. So as you see and hear about more medical applications, we'd love to be engaged with you and your customers on those. So what does this all mean for your customer as we kind of wrap things up? If you are buying Tolomatic, you should be able to buy with confidence. We're trying to instill both within our distribution group as well as in your customers that you can trust Tolomatic. We're a partner with you. We're going to be with you when things are going great. We're also going to be with you when things take a sideways turn and something unexpected happens. We have proven technology. I think everyone, if you've worked with us for very long, you know that we stand behind our product. We err on the side of trying to assume that perhaps we did something incorrectly and get the customer back up and running. And then after we've figured out what the situation, we work out, sort of what actually did happen and how do we try to resolve that and make sure that it doesn't happen going forward. And as always, you get great customer support from our regional sales team, our applications team, our customer service team, but we also pull in our engineering team and our operations teams to resolve a lot of these customer situations also. So if things aren't happening the way we expect, you've got support here for the life of the product. And there are examples of us replacing product that have been out there 10, 15, 20 years. So you also have a longevity to Tolomatic's commitment on supporting our products out in the field.